Okay, good morning all. Session today is on networks and operating systems for IoT. I've slightly switched around the order of presentation in the slides. If you've already downloaded the slides, I'm doing the final third first, and then the later one. I've just re-uploaded it to reflect that order. It's all still there, but it's just a different order. The labs this week, you'll be using MySQL Workbench, or certainly MySQL, to store data off your sensors. You'll be collecting the data, sending it across to a server, right into a database, doing sort of live streaming of that to the database. And the lab exercise will be to get that little demo working where it stores the data, and you'll write code to retrieve it. As well. So if you're working on your own laptops, your own sort of machines, you'll need MySQL Workbench for that. And I've emailed out connection details to you early in the term, remember about 9th and 10th of September, something like that. Do a search with your email for MySQL, one from me that mentions your username, and I think it says PW for password. Try to avoid putting the word password in emails. Attracts too much attention from people scanning the email. So you need MySQL Workbench. It's already on the desktop machines in the labs. And it's similar to last week when you were using that MQTT. I think it's a bit funny about using Wi-Fi ports. So if you use the _BT Wi-Fi here, or your own hotspot, you'll be fine for it, or a wired connection. Next week we're getting on to developing Android apps that connect to your sensors, both to control things like the motors and lights and to receive the sensor information. So for next week's lab, again, if you're on your own machines, you'll need Android Studio for that. So just make maybe I don't know what version they've got in the labs, it's whatever they downloaded in the summer. If you're wanting to get the version exactly right for the studio, maybe just sort of start it up in one of the labs and see what version's running. I might do that and just send them a mail message out. But today's session, as I say, is on these sort of networks and connecting together devices. The demo that I want to have a look at today, just to give you a quick demo and pass some of these things around, is to show you Google Glass in operation. And I'll sort of pass that around. It's like a little visor that you wear with a prism that reflects a screen onto you, and you get that sort of screen just in the top right of your vision for it. On the side is the processor, and the battery is just in this thing that sits over your ear for it. After you use it for about half an hour, you find it heating up, frying your brain and things like that. They did stop the release of these. They released them and then sort of came out of it after we got a bad public reaction to it. People were bothered about being filmed in public and in coffee shops and stuff like that. They've re-released them really just for commercial use, for sort of professionals using them really, until the image picks up a bit. I'll give you a quick demo of it and then pass it round to have a look at. The side part, the actual electronics of it, can slide off and put onto a custom glasses frame. I have one of my own made with it. So like whatever your lens prescription is, you can get those, and then that sits on the side of it. And it projects an image, as I say, in your top right field of view. At first it's a bit distracting, and you'll hopefully be able to sort of see that when you pass it around. I'll show you how to operate it. But after a bit it merges into one, and you tend to see the two things together. The other demo that looks like it's having a bit of a problem. I was just trying to update the software for it. If you've come across Snapchat, I know it's mainly for 13, 14-year-olds or something like that, but I'm sure we all use it at some point. These are some of the Snapchat glasses, a bit more perhaps socially acceptable. They look like sunglasses. They've got a little button on top of the left-hand arm that takes a small video, like 10-second video, or takes a picture for it, and you get a visual clue that's going on with the little white light going round. So it's not quite perhaps as intrusive as the other one. A bit more, as I say, socially acceptable in that it looks like glasses, and it's a bit more obvious that something's going on when it's doing it. Not nearly as much functionality as the Google Glass to work on. I'd show you a demo, but I can't. The software keeps updating on my phone, and it's having a bit of trouble contacting the updates. But I'll pass those round. The other thing you can really sort of have a look at on them, you'll see a little charging point, and as I say, it's a button over the left arm to actually take pictures, and that will probably start the lens flashing the little light on it. I'll show you what the software is supposed to look like. I'll pass one going around this way and then use it up. The other thing to have a look at the Google Glass, and I'll just hopefully connect these so you can see what I see on it. That hopefully is what's on my phone here. Makes it all respond a bit more slowly. I've connected that then to the Google Glass screen, so hopefully whatever I see on my little view screen should appear on that. Give it a sort of try. It's controlled by tapping and swiping the bit above your temple. The tap activates it, and then the swipe goes through the menu options, or swipe down, I think, cancels. So there, that's what I'm just sort of seeing currently on my one. It'll go by. It's activated either by tapping and swiping that, or by voice. So I can say, OK, Glass. A bit of a light between the two. I'm seeing a menu, and that's not something currently appearing. Take a photo. There's a camera in the front of it, That then starts sort of looking out, and as I said, unfortunately it's not being updated. OK Glass, we'll take a picture of it. That's great to see that sort of in the front. And send to McPont. You can then sort of email it off to people. So as it's coming round, well, there we are, there's some good things there. That's the menu item. As I say, a bit behind now. I can bring up the same thing. Don't know this because it went out to read with OK Glass. Take a photo. And that's hopefully the sort of image. OK Glass takes it. Send this to a list of people. Nick Whitaker. Oh, all right, random person. So that photo then just been sent off. You can send it out to your Facebook group, that sort of thing. Another demo. OK Glass. Find it. Explore the stars. What this does is present you with a star map, and wherever you happen to be looking, don't know how well that's, as you look up, it sort of changes your star view to what's above you at that sort of particular point. I think you might be having trouble streaming it to it. But I'll pass it round anyway, as I say, to have a go at it. As it's going round, might have trouble just getting it to reflect. I'll turn off linking it to the screen because I think that's slowing things down as well. As I say, swiping down should go up and make a level. A tap on the side will wake it up, and you can either do it with swipe controls or speaking to it. When you put it on, you may not want to put it on if you remember everybody else's nose sitting on, but it's just worn like a visor, basically, and you can adjust the lens to go in and out to sort of get the focus right. I've worn it over glasses as well to find it, but I'm not sure how many images you might get to see. We'll pass it around to try out. But this works in a similar way to how all nodes work. That is a node in itself, in that it's got a processor, it's got some sensors in it with the camera, the touch device on the side, it's got a speaker in it, those sorts of things, basically a little PC in many ways. But it can then communicate with other devices. It gets its internet, it has got Wi-Fi built in it, and that's why the battery life is quite low on it. It'll last about an hour before it gives up. I mean, you have to recharge it. I'll gather that, yeah, some money to get the Explore Stars working for it. But it can sort of hop then through your phone. Currently it's linked to my phone as being a gateway to other things to sort of work with. I see the image okay there, Carla? Yeah. That thing may take ages to go over, but we want to spend 10 minutes with it or something like that. For working. The sort of things I'm going to look at today will set you in better stead for the assignment as well, particularly the third part of it where you have to design a system and how they all link together. The labs will help you with the first two sections. Certainly the labs that we've done up to this week will be enough for question 1, and then next week you'll be on with question 2 as well to sort of work with that. So I'm just going to disconnect that. Give you an idea of what the Snapchat sort of thing was supposed to be looking like. oh, there we go, picked up something. 6th of October 2018, it just took a bit to upload to it. So that was one of the images supposedly was sent from the glasses today, or the videos. That's me just trying to get it working. Not a particularly productive video maybe, but just to sort of illustrate the idea of it capturing it sort of live. You might find that it's still working and it might be sort of transmitting to this. As is often the case, these things can just be sort of a bit, you expect an instant response, and they can get a bit sort of slow to respond there as it's sort of picking up. So I think that was, yeah, again, some sort of old videos just as you were arriving, as me trying to get it working. But it's just really a fun thing, that. You know, there's no particularly great use to it. It's just to capture, you know, a pair of sunglasses, capture things as you're going along by sort of tapping and the like with it. Yeah, well, it looks like it was actually capturing all those things. It just wasn't uploading it to the phone very quickly. It's not sort of instantaneous to the phone. It might sort of do it over the next few minutes to sort of work on. But I'm not going to sort of work through all those, so I'm going to cancel out the Android and get on to what we're actually, the main part of what we're doing today. Today's session on these network and system software, sort of operating system software, is probably about the most theoretical one that we're doing to it. If you like, a dip in terms of things to pick up. There's a lot of sort of technical terms cropping up in this, and lots to do with sort of network protocols, operating system things. Not going to dip into it too deeply. The people who've probably done the network and operating systems module, this will be really old hat to them. But equally so, people may not have done sort of too much on it. But it's to have a look at what these sensor networks are supposed to be able to do, and what sort of network protocol you'll choose in terms of wireless protocol, and also as your message gets from the actual device out to some server somewhere, and now it's got to bounce through different nodes along the way, how you might do the routing of that to sort of work with. Basically, these sensor networks, you've got lots of nodes about, all with different communication protocols. It would be great if everybody spoke the same language, if everybody spoke the same network protocol, but they don't. Different devices use different networking protocols, heterogeneous sensor nodes. Some are broadcasting out in Wi-Fi, some in Bluetooth, some in this Zigbee, some one. They're spread out over a physical location. It's rather like having sort of disparate people spread out, all speaking different languages in different sort of places. And how do you get them as a whole to communicate? These sort of sensor nodes, they've got the physical sensing part with it, maybe do some data processing. An ad hoc network is where you've got these devices that can come and go, like in a sort of Bluetooth network where either the device gets turned off or its battery power runs out or it goes out of range or something like that. So the network's got to be able to cope with sensors leaving and joining that network, and this mobility and failure of them. And where is this data processed? You're streaming in, say, all of this slider data, push button data, temperature data, whatever. Are you sending on every single one of those? Like last week in the when we were broadcasting out with MQTT, and you were moving that slider or perhaps pressing a sort of button. Do you really need to send a message 30 times a second or 1,000 times a second? People don't really need that temperature updating that much. So you might process some directly on the node and say, well, let's ignore a lot of it and just send a value every minute, or let's take an average or a moving average of values to take. Or it may be that some centralized node collects in values from around it and then aggregates all those collective values and sends across a collective one to it. So there'll be some data processing going on somewhere in that network. Because the sensor nodes themselves are typically low power. They're the things that are independent with a battery power in them, so they're really resource constrained. They can only run small processors. They're not going to be running the latest CPU and running an operating system like Windows 10 or the Mac OS X or something. They'll be running a tiny operating system, and they're wanting their prime purpose is to conserve power. Because they typically sort of battery powered and they're not always as accessible as other ones. Whereas a sync node might be something that's got a bit better resources, can communicate with its neighbours, but can sort of collect together that data in some way, act as like the group leader almost to sort of collect together. Might have more powerful and better resources, but it makes it more expensive than these sort of standard ones. Now the things you develop in labs, they are nodes. It's just that they're very powerful nodes and that they've got a full-blown power supply to it. They've got Wi-Fi and Bluetooth on your laptop or your desktop sort of machine. But typically we're talking about something like substandard to something like a Raspberry Pi or some sort of micro node really running these. But somewhere in the network as well you'll have this gateway node that's then linked to the outside world. The gateway node typically has got a power supply to it and will be connected in some way to either Wi-Fi or a wired connection to your router, that sort of idea to work with. So it will have a power supply to work with. And that's how a lot of these smart home systems work. You get some sort of gateway node that will plug into your router, and they, as I say, typically have a power supply, and then you'll have your sensor nodes that you'll dot around the house, or dot around the building, dot around the outside, somewhere like that. Maybe these sync nodes between them. They're responsible for sort of keeping in contact with them, a bit more like beyond the group leader, like more like the course leader or something to sort of be working for. And the sorts of things that you're typically responsible for are things like this event detection. We've typically in the labs, you're only really playing with a slider most of the time, and that's only because you can accurately control that to send sort of values out. But you've got these force ones and touch ones in there, but they're normally detecting some sort of event for it, possibly in collaboration with other devices. And possibly sending these things periodically. They don't have to do it as the actual data comes in. You don't have to send it off to your neighbour or your service immediately. You might restrict that, or you might restrict it to a certain percentage change. You might say, well, only send it on if it's 10% different than the previous value. So you don't sort of send it if it's got a tiny little change. It's like saying, well, you can detect where I'm moving. Well, I'll just move an inch forward then, or something like that. That's irrelevant. Whereas if I moved across the other one, you're going to have to do something, probably like, let's turn around and see where it's gone, something like that. Whereas a small movement, you don't necessarily have to sort of detect. So you've got these periodic measurements, and perhaps bits on pattern detection, where some of these sensors might be detecting sort of heat. And you might detect things like the edge of a fire, where something's going on, or the front of something, like a weather front moving along, or a tsunami sort of thing going along, or a fire moving along. You can have sort of boundary patterns, and then sort of estimate where things are going to be. We'll get on to the whole business of tracking as well for that sort of thing. You might have to build some sort of fault tolerance into these things. That will depend really on how expensive your sensor is. And as I say, something to do really with that battery power, how long it's going to last. But these are the sort of roles or requirements and challenges that nodes have got to sort of fit in with. How long can they last? And is it scalable for something? How many nodes can your hub, your gateway support? For example, the Philips Hue supports something like 500 lights or something like that. So as long as you've not got more than 500 lights around your house, you'll be sort of okay. That's what it's sort of aimed at. But if you've got a larger scale system where perhaps there's thousands of sensors, you might want to approach it in a different way. That's something that we'll just be having a look at later on. So the sort of the node densities can make an effect. I mean, you come across that sort of thing really where you've got Wi-Fi access points. They're fine as long as you've got 50 people attached or something like that. Get 500 people attached to an access point and everybody suffers. Like if you've got your home network and your router and somebody's torrenting in, streaming in films or something like that, and it kills it off for the other users in the house to sort of work on. Other things that would be useful to do, can you program your node? Can you write some software on it, or does it just report data back? You've been programming the node so far. You've had these sensors picking up data, and then you've written code in Java to interact with them and decide what to send on. Now that's because you've got an operating system that supports a programming environment. You're using Eclipse to write this software in. You're writing in Java, you're writing the code to interact with the sensors and broadcast it out. You need to think about, well, where are these things actually going to be deployed? You're putting it onto a Raspberry Pi that might not support having Eclipse on there. Might be a different sort of operating system or something even smaller. So you need to think about, like, if you're writing your own software, what language or what can I support on that? And it may be that you develop it on a work machine, if you like, and then transfer the software across to your node to work with. So there's all sorts of trade-offs that might come to all of these. Networking. Working with these things, as I say, working out in the field, you need some sort of network capability that's not going to be too power demanding. So it's got to be sort of energy efficient. They've perhaps got to auto configure. It's not like a Windows machine where you can go in and say, well, let's just download the latest Windows update or something, or update this, and it's a nice little user interface. It gets a bit sort of trickier to auto-configure and update these sorts of things. It's just because it's on such a lower scale, it gets a bit sort of tricky to work with. Now let's just have a look at the sort of communication that you might do. There's different protocols to work with. You can have wired connections, like Ethernet or USB. That's what you've got with the sensors in the picture toolkit. There are USB, the wired connectors going in. They're not sort of wireless in there. You might have these wireless ones that are working over Wi-Fi. One of the ones that I passed around last week was a little room sensor, a little white plastic box that picks up values and sent them out. That was Wi-Fi connected. Others will see Bluetooth, Zigbee, these other wireless protocols. They tend to focus mainly on Zigbee now as the main wireless protocol. Other things we'll have to work out about whether or not you're doing a single hop to your destination, or are you doing a multi-hop. And we'll sort of look at that just in the second part of today. So there's a variety of protocols out there. Really, it boils down to what the power is that you want to be able to use, minimal, and how fast do you want to be able to transmit this sort of data. How fast can each side cope with it to sort of work on? Do you have to send it out at a slower pace? I mean, myself at the moment, I'm using a voice protocol to project these things to it. I could send it out as a written protocol and hand you all the sort of document. That would take a lot longer to do. You'd have to receive that document and read it. It's much easier just to listen. But equally so, even when I'm speaking in a fairly measured way at the moment. I could speak a lot faster, and hopefully people keep up with me and follow what I'm doing. But actually, from a different country, you might not understand every single thing that I'm saying and pick up these things. I'd get my lecturing a lot quicker. I could get the same old information by blurting it out and increase my frequency, if you like, of speaking. But it puts a lot more stress on the people picking it up to actually follow that. to pick the information up going through. So that's the same sort of approach that these wireless protocols are using. How fast can they blurt the data out? Because it takes more power to broadcast it out faster and get it done in less time. So that's what all these IEEE standards are for Wi-Fi networks and things. But we're not here to remember every single number. It's not a sort of numbers game of remembering all the megahertz frequencies that these things are working on, or what bandwidth they're operating on. Just to get a general idea of what the rough comparison is about which are the faster ones, which are the slower ones, which use more power, these sorts of things. So you've got these standards like Bluetooth and what sort of data rate they're at, or Wi-Fi, and again what sort of protocols they're using for it, GPRS for phone communication. They've all got their own speeds, and you're probably aware of a lot of these sort of things of when is it better to use your GPRS connection, i.e. your phone connection, and when's it best to use Wi-Fi? It might be down to how much you're paying out, but in some cases one might be a bit sort of faster than the other to sort of work with. But when we start working with low down nodes, things that are working on, as I say, sort of low power, small processors, they can't all necessarily use these newer protocols, or protocols that demand a high amount of power to sort of use for them. For example, there's an operating system for low power devices called TinyOS. This tiny operating system, based on C, got very, very little capability. It's just really aimed at that sort of small processor market. It's not aimed at games players, it's not aimed at playing videos or anything like that, like your bigger operating systems are. It's aimed at just doing the things that are doing one job well for it. And then you have network protocols, again, sort of built around that, like sort of Zigbee to work with. The idea behind Zigbee, it's been out for sort of a good few years, and this has come to be almost the dominant protocol for IoT devices. You will find Bluetooth as well, and you will find Wi-Fi, but this tends to be the sort of dominant one. Slight bit there about it, yeah, for the numbers people, about what megahertz it's working on, but how fast can it send its data? What speed can it transfer at? 20k per second at some sort of frequency, 250k per second at another frequency. So again, that's rather like, as I say, either I'm talking in a measured way and I can get over so many words per minute, or I can talk very fast and get over a lot many words per minute if I speak sort of faster. So you get a different sort of one for it, but a bit more sort of power behind. Now, one of the good things about Zigbee and why it's picked up is its data transmission is okay for Sentinel. It's no good for streaming video. It's no good for working on a standard machine. But that final point there, Zigbee knows we can go to sleep to active in 30 milliseconds. Now, if you compare that with sort of Bluetooth, when you switch on a Bluetooth device, and you get this little pairing thing coming up, sometimes it says on your speaker pairing, sometimes you've got this message appearing pairing. It takes it 3 or 4 seconds, it's maybe 5 or 6 seconds or so to actually get that link working. Zigbee nodes can go from being asleep to active in 30 milliseconds, so that's 30,000ths of a second, 300ths of a second. So really instantaneously wake up. So as soon as something happens, boom, it's awake. And then can start working with it. Now what that means is that your device can spend most of its time asleep. It can sort of be sleeping in really low power mode, and then it can wake up to start transmitting. It can sort of perhaps detect that an event's occurred, decide that it needs to send it out, and suddenly wake up its communication module to be able to send it out in very sort of a very sort of low time to do it. As I say, now that is one of the things where it compares very well with the Bluetooth. In terms of speed, I think Bluetooth might slightly have the edge to it. Oh, I'm not going over that sort of diagram. That's a bit too sort of techy for it. But in terms of how fast these can send out, if you like, which ones are better than others. We've got the sort of Bluetooth and the Wi-Fi on top of that. This Z-Wave is a bit sort of faster. It's like which communication protocol are you going to use? What sort of data rate are you going to send out at, ranging from that sort of 10k a second to gigabytes to sort of work on. And things like your Zigbee, NFC, similar to your RFID, they are down sort of quite low data rate to send out, but they're not actually sending that much data. If all you had to do in this, say, in this lecture session was get over sort of 3 or 4 slides, then I could spend 10 minutes on each slide or something like that. Whereas if I've got 60 slides to get through, then I'm going to sort of push it through a lot sort of faster. You can get an idea of, depending on the volume of traffic that you want to send, which one might be the better approach to it. Just because it's slower doesn't necessarily mean it's worse. It's probably taking up a lot less memory space, a lot less sort of power usage to get it. That's the thing that's sort of going to increase. And when you're linking these nodes together, about how you pass on the information, because as I say, one slave node may not be able to send it too far. I can be, again, sort of giving this analogy of me and here, I can be delivering this speaking session, but I can only reach perhaps towards the back of the room. So if they can't hear me down the other end of the corridor, I'm not broadcasting that loud. So there's a certain range to what it can get. Now, if somebody wants to listen down at the end of the corridor, you've got to have some sort of way of relaying that out. And the different sort of topologies are really around that. Like you can either have, say, a centralized one, this star network, where everybody just talks to a central node, and that passes on the messages. Or you can have that sort of final one, a mesh network, where individual nodes can pass the message on as well. The difference between, well, the final one means that you can have much wider range of things to sort of work with. But each node has got to be able to, as well as transmit your data, and that first one is transmitting it to the hub of that network, they don't actually have to do any listening. Whereas if you had to be able to pass messages on through the mesh, you have to be able to listen to your neighbour to say, okay, well, I've received a message that my neighbour there, the bottom left person in that mesh, may want to talk to the internet, and it has to pass it through that route to get there. What's the best route to use as you're sort of moving through? Again, that's just something that's cropping up in a moment. So in terms of if you've got multiple nodes about, what's the best approach to take? Most tend to work with this star one. The Philips Hue bulbs work with that mesh network. They can extend their network out over an entire house by each bulb passing on information to another one. They all know who each other is. You can send a message out saying, tell the bulb in the living room to turn on, and it passes the message through. One of the reasons for that is that the bulbs are plugged into the electric supply, so there's no shortage of power there for it. Whereas if these things have got to listen and transmit, then there is a sort of problem with communication. You've got to be listening all the time. You can't go to sleep for a bit. You've got to be constantly listening for what's going on and passing it on, and hence perhaps using more sort of power. So in terms of power consumption, that's a very rough guide to what we are. The Z-Wave Bluetooth, it's sort of down at this sort of bottom end compared to the big fat battery used by sort of Wi-Fi. So when you're doing this question 3 of your assignments, you're going to be sort of designing a node layout. You need to sort of think about, well, what's the best protocol to use at each stage? And it won't necessarily be the same all the way through. Your final one, your hub, maybe wired connection using an Ethernet cable. Your sync nodes might be a different sort of connection as well to use. But there's an overall table summary there of speeds, how long it takes to sort of wake up, a typical length of a battery, those sorts of things, just as a reference guide. Now, in terms of some of the protocols that we're using, let me just flick on a bit past this low pan one. Get to the main part about these network protocols. If you've got this sensor network, and that's just sort of like a sample diagram there of all these nodes. So these are the independent nodes. They've got their own battery power, their own sensors built in to it, and they're perhaps trying to communicate with a gateway node. That communication module is trying to do that data linking part to it, and there'll be networking capability built into the hardware. We're concerned really with linking these things together, and as I say, maintaining a reliable connection. We might have these different sort of types of network. They talk about wireless sensor networks, ad hoc networks, which are really like Bluetooth ones, for vehicular networks working with it. Different types of networks sort of crop up. But the main concern generally is how well do these networks perform? How reliable are they to sort of work with? And how do you deal with management of these as new nodes come along? How do you add a new node to the network? Rather like you join the network, say for your Wi-Fi. The first time you approach a new environment, you go into a new coffee shop you've not been in before, we have Wi-Fi. Okay, you have to scan down it and find the Wi-Fi thing and join it. So there's that bit about the management of adding these nodes, deciding which sort of speed they can work on, because Wi-Fi's got 2 speeds it can work over, allocating addresses to people. All these sorts of things are just network management operations. And then you've got the bit about, once you're actually sending them, how do you route through from one side to another? And just to give you an idea of the problem, this is not something you'll need to do for the assignments. So immediate switch off. Not something you need to do for there, but just to sort of in the background, how you might route from, say, one part of it to get over to the other one. What's the best way through? So if I've got to get, if my message has got to get from here up to the sort of back row, I mean, currently I'm broadcasting out. I can speak in a low voice to someone, because that's maybe my range. And somehow, we have to get that message back. So it's like sort of this sort of game where you pass on a whisper and somebody picks it up and then passes it on and the message gets mistranslated along the way. I could have a preferred route and say, okay, well, my sort of preferred algorithm is whoever's on the end of the row, can you pass it to the end of the row in the row behind you? And that might be one routing technology to use. And that might be the actual algorithm that you use it to sort of say, end of row people pass it back. Trouble is, if somebody on the end of the row is asleep, something like that, then the message stalls. They might have a bit of a speech problem passing it on, they may not speak the language and it sort of halts. So there's other approaches you can take. Things like flooding the network. You can sort of send a packet of information out, say a sentence out or something, a packet of data out, and each node who receives it just rebroadcasts it. So I say one sentence, and then whoever hears it says that sentence as well, mimics it. And so then it goes a bit further, and then whoever hears that broadcasts it out. Now, it's very simple. Anybody doesn't have to remember anything, but it's really wasteful in bandwidth. If you started sort of saying a sentence and then all you lot had to repeat that sentence and whoever heard you had to repeat that sentence, then there's too much sort of going out. But it's really easy to implement. The other idea maybe is to have some sort of source routing where you can say, okay, the source node can specify what route to take. So I might say, this analogy of me sort of speaking in here, I'll pass it to this first person and say, you decide how to go on from there. I can see up to 3 rows behind, can you make sure it gets to 3 rows behind you? And then when it gets to there, they can maybe sort of specify the route to take. So you can sort of specify a route to take, partially or completely, And it's up to the source to be responsible for finding that initial route. I'll say an initial thing in here might be straight up the end person on each aisle or something like that to sort of work with. It could be based on distance. What's the shortest way there? Another analogy might be, say you're giving traffic directions to get from here to Manchester Airport. What's the best route by car, say, to get from here to Manchester Airport? Ask everybody in here. A lot of people have said, I don't know. Other people have different sort of ideas. You know, they may say, oh yeah, well if you sort of get up to the M60 or something and follow that round to the M56, then you can sort of take the route out to the sort of airport. Well, they say, no, not at this time of day. It's far too crowded. Your best thing is going up to Didsbury and then getting on the M60 or something up there. Is me showing my complete geekdom or something like that maybe. I don't know a huge amount about map routing, or some people just say follow the sat nav for it. But you might sort of work out distance vectors, and you might say, well, let's take the shortest distance. Now, what's the shortest distance? Does that mean physical distance in kilometres, or is it distance in terms of time? How long it takes to get there? It may be a short distance to get there by road, but a longer time because of the sort of traffic going along. So distance vectors, working with neighbours, means you have to set up some sort of routing table, work out what's happening along the way, a bit of local knowledge. So I might say, well, let's get to Didsbury and work it out from there, and then some local in Didsbury says, oh, main road to here is really bad today, you're better off going this route as you're sort of going through to it. But you maintain a table of which route to sort of work through. And there's quite a lot of these sort of techniques. Not something, luckily, that we as a software development course have to bother with. That's handled by your networking technology. That's the things that your telecom people do in managing their broadband sort of network. Perhaps you might get a choice if you're doing it in a network inside a building, and they say which sort of routing one do you want to do. But just to give you an idea, sort of pick up an example of one. Say you're wanting to get from A to H. You've got this sensor network or routing network or whatever, and they're the connections that are available. What the flooding method does, A just sort of broadcasts out, I want to send this package to H, and tells B and C. C is only connected to B, so tells B, and hopefully B ignores it. B is sort of when it receives a message, broadcasts out to D and E. D broadcasts out to E, H and G. So it depends on who's sort of connected, but each one's sort of broadcasting out. And eventually, you'll get there, even through sort of flooding, and the destination can track over, you can ask that packet, where did you come from? Which nodes did you go through to get there? So in that case, it might say, well, I went through A to B to D and then to F. That can't be right for that. But it can remember its route. And when it passes, it can pass an acknowledgement back to say, yeah, this is a good route to take. So today, this route through this one currently is good. So any more that you're sending, can you just sort of send that route to sort of get through? So yeah, you are flooding, but you come out of it with a route that you can then tell the people after. So the explanation behind that is that the source broadcasts a request to get somewhere. Each node includes where it's come from. So A sort of says, well, I'm starting from A, B receives it, and then passes on saying, well, I've come from A, then to B, and then here's where we're up to, to D. And then D says, well, I went from A to B to D, and then the next one sort of along. So each node includes the path of where it comes from. And when the request gets there, the destination, you can do a reply saying, this is the route to take. This is the best current route for it. It might be seen it sort of multiple times. You can sort of time out which, evaluate the times of which ones was the sort of best one. But each intermediate node uses that path info in its header to forward on later ones. And nodes, each node maintains a route cache. They say, well, if you're receiving something, what's currently the best thing to do? And it holds a cache of the routes. And already these things are getting, these are the tasks that each node has got to do. So if you're talking about one of the, each node might be just one of these sensor nodes, you've got to have something on the sensor node, particularly if it's in this mesh network, it's receiving a message and forwarding it on. It's got to have this sort of algorithm built into it. And it's got to maintain a cache of the routes going through and be able to receive a message and pass it on, even though it's not necessarily about that node itself. It's got to sort of pass them through. So it just means that all these things mean that the individual has got more things to do, hence more power to do it. And it's given us sort of an idea of why some of these networking requests do take some time to sort of do. So you put in this is a bit of a tricky diagram to sort of follow, if you like. The blue being the routing request, and then a routing response. So as you're going through, you can sort of follow each one saying that very top one saying, okay, as I'm talking to B, I've just come from A. And then B talks to D, I've just come from A to B. And then when D talks to H, I've just come from A, B, D. Or it might talk to G and say, I've come from A, B, D. And then G says, I've come from A, B, D, G. So at the end of it, your destination will know the route and can pass in that response saying, which is the best one? A, B, D, H, there to sort of get through. And all these intermediate routes can then sort of remember that best route through, which is the best one, and sort of for future ones coming up. Very ridiculous sort of ways of timing and distance and things like that. Don't worry about that sort of one. Now the rest of these slides just go over a few more routing technologies. And the purpose is just to give you an idea of what's going on in the background of some of these. Not that, as I say, you'll have to ever sort of implement them, but you may come across some of the terminology as you're setting up your own sensor network about what's sort of happening to it. And there's a few worked examples going through, but nothing that you need to, as I say, really use in the assignment, but really is this sort of background reading, background understanding on these network paths as they sort of go through. So I'm going to leave the rest of the sort of networking ones, which is really just sort of saying, how do you decide which is the best sort of performance one? And we're on about 10 to, we need to get to this at about 5 to. So the second part of today, about the sort of performance and the operating systems, I'm going to kick off with next week. These demos sometimes take a bit longer than needed. So we'll leave it there, but I'll finish off this little bit, part of this little bit next week. Okay, we'll leave it there, thank you. If you didn't sign the register, just here at the front. Can I have my glasses back as well, by the way? £999 for the Google Glass. It's not expensive.
Yeah.
Oh, well, I've got them on a separate sheet. But yeah. Oh, yeah. Just email it. Hopefully, just check it. Just check it.
Yeah.
I don't really want to go on 40 games. Yeah. That one was a Unifund one, yeah. Yeah, £999 quid it was, yeah, when we bought it. Ridiculously overpriced. That's another reason why they never got through with me. Yeah. I'm hoping it comes back down somewhere. Somebody got the Google Glass?
I do indeed.
Done, thank you. We're just hoping to walk out and unnoticed. Higher.
Cheers.
Okay, right. Have you got access to the Google? Well, we're basically we're pretty much sticking to that. So whatever was done in previous weeks, we've done. But they're sort of cumulative. in that, you know, we really need to have done the one before. We can set off with today. We can still do today's live. Oh, well, it depends which time you're in. One today and one on Wednesday and one on Thursday.
Afternoon today.